Hello. Um, Hi guys, welcome to the class. It's me Akash. I'm a certified data scientist from IBM, and I've done various projects on data science and machine learning. So basically, I'm here for the instructor for this course to you, which is about this machine learning. So let's talk about machine learning. What is actually machine learning? So when we have in mind, so first thing that comes in mind is an AI. So AI is, you can think of as an you can say superset of all. So we have AI, and then we have machine learning, you can say ML, and then we have deep learning. So deep learning is especially about neural networks. You might have seen the deep neural networks and LSTM, RNN, the most advanced things today in deep learning. And then we have some classical and statistical machine learning models such as support vector machine, KNN, and other linear regression and all. So they comes in machine learning, and then everything such as the reasoning and some psychological things as well, and some of other things like game playing and all the searching problems, they come into the section of AI. All right. So let's talk about what is an AI and what is machine learning. So when you talk about an AI, so artificial intelligence is something. There is a human intelligence, and then there is some term artificial intelligence. So any kind of intelligence means reasoning, which you can develop onto some machine. You can think of it as an artificial intelligence. Okay. So other than machines, you cannot. Other than machines and some human or some living things, you cannot develop intelligence in somewhere else. Okay. So so other than a living thing, which are the plants and humans, and other than living things, you cannot develop intelligence in anything else rather than machine. So that we call if any system is capable of thinking and reasoning, drawing some decisions on its own, that we can think of as artificial intelligence. So it's using some kind of intelligence, and it's artificial. It's not biological, or it's not a living thing. So we can say that it's an artificial intelligence. Okay. And inside this, as I told you, some searching problems, and some psychological things, and there are so many other stuffs that comes inside it, like game playing and other stuffs as well inside this AI. But when we go deeper into the machine learning part only, so in machine learning, let's say understand what is machine learning actually. So learning is any process by which system improve the performance from its experience. So learning by seeing the data. So we have some find out some algorithms so that we can tell the machine that this is the data, and the let machine find what is actually the hidden pattern, what is the rule by which they are actually dependent, the input and the output. So so this is something we can call machine learning, and deep learning is a subset of machine learning, which we actually use neural networks to actually perform the same machine learning task. So let's understand what is a traditional programming. So in traditional programming, when we make programs on computer, what do is we have data. So let's say we have computer, we have data, and we have the program. We have the data, and if we run the program on the computer, then it will give me the output. Okay, we have the program, or you can say we have some rules. Okay, we have some rules. So we will give the data, we have some rules, and then program will give me the output. Let's consider a scenario that I have a data like A and B, and my rule is that I have to sum them. Okay, and then and this is the rule. As you can say, this is the rule, and this is output actually. So your program actually, your computer will take this input. Let's say we have 3 and 4, and then the output will be 7. Okay, we have 3 and 4, and the rule is to sum them. Then output is 7. Let's say I have 2. I have 8, and the rule is to multiply them. Then the answer will be 16. All right, and so on. So this is called, you can say, classical programming. So this is our traditional programming that we do in the computer. And what is machine learning actually? So in this machine learning, you have some algorithm, and in there you will give the data, and you will also give the output with the data as well, the output or the result you can say, and then it will actually give you the rules. What are the rules that they are binding this input to the output? Okay, so now let's find out another example, the same kind of example. If I try to see the same kind of example in terms of machine learning. So let's say I have some data. Let's say A and B. Again, I'll take 3 and 4, and then I will say the result is 7. Okay, the result is 7. The output is 7. My A and B are 3 and 4, and let the machine find out what are the rule in between them. Is that addition or is that something else? Okay, so we can think of it as the machine learning task. Okay, this is how machine learning performs. And machine learning, this model does not understand the things by only one set of example. So machine learning requires a lot of data. So by this you will give hundreds of examples. So you will give hundreds of examples, and then this machine will able to understand that okay, the thing is actually the addition. So just for only one task, let's say it has to find out the rule of addition. Then for this you will have to give a lot of data, and then this will find out that okay, this is my task actually, and the rule is actually the summation of summation. So when do actually we use machine learning? Okay, so let me so when I ask a question, when we actually use machine learning, and why machine learning is actually booming this time. So before this we do not had the power of computation. Just hold on. Hello? Yeah. Okay.
नीचे से वाटर चलती है।
All right. Okay, so now let's say if I simply start. So where was I? Okay, so when do we actually use machine learning? Let's say how did machine learning become so popular in this recent era is that basically for machine learning, as I told you, we need a lot of data. So to perform any task, let's say you are doing some image classification. So to do the image classification, you actually need to have a lot of data for each classes of image. Let's say you have images of two fruits. Let's say you have banana and you have oranges. So if you want to actually classify them, then you will show this machine a lot of pictures of banana and tell that it is a banana, and as well for the oranges, again you will show a lot of pictures of oranges and tell that this is actually orange. Okay, so this is how they will they understand that this is banana and this is orange. Okay, so and now if you tell them and give a lot of images. So before that, when before the internet and before this a lot of things that happen in that changes the user using a lot of data and gathering a lot of data on the social media and all the stuffs, and So after then, there were I can say a lot of access of the data. So when the internet became cheap and popular, so people started using smartphone and all, they started generating a lot of data, and then we had data. And then in recent year, we developed our system so powerful that we are capable of performing a lot of you can say processing power. We have a lot of processing power in our mobile phone. We have a lot of processing power in our laptops. So combination of this data. So though we know that actually this machine learning takes a lot of data and a lot of computation power. So when we have excess of data and when we have the computation power, then we actually the result of this, you can say, the boom of this machine learning thing in recent years. Okay, so this is the reason behind that. And let's say if I talk like when we can use machine learning. So ML is used when human expertise does not exist. Let's say when we can say that if we don't understand something and then we want to find out what is the hidden pattern in there, then we can use this machine learning. And let's say human cannot explain the human cannot explain the hidden behavior of some phenomena, then we can use machine learning over then and let the computer find what is the relation between them. Okay, you can say the models must be customized, that should be focused on some specific areas only. And models, or I can say there should be actually huge amount of data. We should have huge amount of data on any topic. Okay, so let's say I'll take an example. Let's say I have a bunch of digits. So let's say I have handwritten digit 1, okay, image of 1, image of written 2, image of written 3, and so on till you can say 9, or you can say till 0 actually. So I will show these things to image to machine. Let's say multiple image, let's say thousands or millions of image of 1, and then the machine will able to learn that okay, this is actually a digit 1, and same you can say number of digits for 2, and same number of digits for 3, and then the machine will understand okay, this is 1, this is 2, this is 3, and when we show them the new digit written by someone else, let's say this, then it will classify this at okay, this is digit 2. So this is how this can be one example of this. How many types of actually problems can we solve with this machine learning? So we can let's say if you want to decide, I can say if you want to recognize some patterns in the behavior of something, then we can use this machine learning, let's say, that we call pattern recognition, such as facial identification or facial expressions, handwriting or spoken words, or you can say medical images. If you have some a lot of medical images and you want to see that which one of them, let's say you have X-ray data and then you want to see that X-ray of the chest, and then you want to identify whether or not some images contains the heart disease or lung disease or something. So you can use these kinds of you can say recognition patterns. Okay, generating patterns, we can say generating images, or if you have a blurred image, you can generate a new crisp image with that. Recognizing anomalies, such as if you have let's say outliers. Let's say there are some fraudster. You want to let's say you work in bank and you want to capture who takes the loan and doesn't repay. So this is something you can say anomaly detection. And prediction, let's say future forecast prediction of sales of any company, or stock market prediction, such as here we can actually use these machine learning things. Okay, these things can be an application of it. And web search, so simple application can be in any of the system, let's say e-commerce, finance, space, robotics, information technology, and so many wide area are open for this machine learning thing in there. Okay, let's say if I the very recent thing that where machine learning has been used is this you can say the autonomous car. So we have autonomous cars. So what do they do is actually in the autonomous car, they take the data from various sensor and let the car decide that what should be its path. It should go forward, it should move, it should go left or right, or it should use brake or accelerator and so on. So based on the input data coming to the car, and it can actually act on the basis of that. Okay. So let's now see what kinds of machine learnings are there. So actually these are the application of machine learning which leads you to be an expert. If you are actually expert in this technology, then you can access the whole world of you can say opportunities. So you have opportunities to any field. You can work in any field. Let's say you have worked on something about medical domain and you have expertise in machine learning. Then you can actually apply this machine learning in medical domain. If you're working in IT domain or finance domain or any domain, you can actually use and power of machine learning. And if you learn once, then you will be actually able to define that what kinds of tasks are suitable for you to use machine learning and do the stuffs more easily. Okay, so this is something that you need to see in your domain, and then you can actually use machine learning, and that will be much more beneficial for you. Okay, let's talk about what are the core types of machine learning techniques here. So if we say the types of machine learning, okay, so first one is supervised machine learning. When we have the data and we have the output as well. Let's say as I told you, I have an image of apple, and there is someone to tell me that this is an image of apple. Okay, or in the data we have a data where there is image and the corresponding label that this is apple. Okay, and the same way for apple and oranges or bananas. So we have the label as well. So this is something we call the supervised learning. And the second one is unsupervised. So we actually have this data and labels. So this label, we can say it is a supervisor. So whenever you make mistake, let's say you classified some data. Let's say I gave you an image of apple and you said this is an orange. Then there is a label to rectify you. Okay, so you will see the label and you will understand, okay, so this is not an apple, sorry, this is not an orange, it's an actually apple. So you can actually compare and see that whether you are right or wrong, and then you can actually make your decisions based on that. Okay, in case of unsupervised learning, you don't have these labels, you don't have these class labels, this the label that you're seeing, apple or orange or something else. Okay. And let's say what kind of task we can do inside this supervised machine learning. The first famous task that can be of classification, and we can do some regression tasks as well. What is the classification? Means this problem that I took, like I have an image of apple, I have an image of banana, and then we have to classify them either of these images. So I will show you one image, and the model has to decide that whether that image is an apple or banana. So we have two classes here, apple class and banana class, and out of these I have to do we have to give a sample, and that model has to decide out of these two class this picture belongs to which class. This is this task actually can be called as the classification. And not only this, there can be so many types of tasks that can be classified as they can be classified as a classification model, classification task. And regression task, in regression task, let's say we have some trend or we have some data, and then we have to fit them with some curve, and in the middle if we have some missing data, so we can predict with the help of this prediction curve. So this something is called a regression model. Let's say if I say an example of can say regression task, maybe that if I have certain if I talk about, let's say I have a car, and And if I say that the car has this many cylinders, it takes the average of the car is this much, and then I have to predict that how much carbon dioxide it will give me per kilometer. So this is something we can say it's a regression task. Okay. Some people actually the third type of machine learning model can be some people say that it's semi-supervised, which has some training. I mean the mixture of unsupervised and supervised learning, but you can think of it as a both as a semi-supervised. But I don't actually I can put them into supervised itself because some of them we have you can say the data for. Some of the labels. We have the labels for some of the data, and we have not label for some of the data. So we can put that in the combination of both that we call semi-supervised. So we have a label for some of the data, and we don't have labels for some of the data. So it's a combination of I can say semi-supervised. Okay, and then the last one is actually reinforcement learning. This one is interesting actually. So what is reinforcement learning? In reinforcement learning, what do we do is actually it's actually based on the total reward and punishment policy. Let's say this is actually mainly used in game playing. If I ask you that I have one game. Let's call it a snake game. So let's say there is a snake going, and there is a fruit. So whenever this apple snake eats the apple, you give them a reward. Okay, and whenever this apple, you can say snake touches the wall or touches its own body, you give them a punishment. Reward means you give them points. You can give the rewards in any manner. Let's say giving them some coins or points, and punishment means reducing the points. And your whole task of this system is to actually increase the reward. So if the reward is decreasing, then the model itself understands that I'm doing something wrong. Let's say if he actually touches his head with the wall, then I will actually reduce its point. So it will understand that this is something that I have not to do, because doing this will actually lead me to reduce the point. Okay, so this is how this machine learning model, this unsupervised machine learning model, this reinforcement learning model works based on rewards and punishment. So when it will actually eat apple, and then I will actually increase its reward, I will add some more rewards into there, then it will understand that okay, this is the task that I have to do. So by doing this of so many times, it will actually understand that what is the rule of this game, and automatically it will able to play the game. Okay, so it is on us that what we actually reward policy and what the reward policy we use and what rules are we are actually coming up. It's on us. And we have to define the machine learning engineer has to define all these tasks. All right. Okay, so inside this, as I told you, in unsupervised learning we have clustering. So in clustering, I'll take an example of clustering. So let's say again I'm gonna talk about this apple and orange and banana thing. Let's say if I have 3 fruits. Okay, let's say I'll take an example of a small boy, because learning of a small boy is again the same as we train our machine learning models. So let's say if there is a boy who's standing, who's sitting there, and you have a lot of fruits in a basket. So let's say you have some apples, you have some bananas and apples, again apples, bananas, mixed together in a basket. And then it actually, you ask the small lad that you have to classify, you have to divide them into 2 parts, and most similar parts will be at once. So we have apple, so the main task is to separate apple and banana. Okay, so what does the guy do is he takes an apple, okay, he puts it here, and next time he picks another apple. So what it will do is actually he will try to see, let's say he picked that apple and put it here, and then he found another apple, and it will see whether it is similar to this one or not. If it is similar, then it will put again in the same basket. If it is not similar, it will put into the different basket. Let's say if he picks banana next time, so what it will do, it will put that banana into this basket. Remember, the small guy do not know that this is an apple, this is a banana. So this is why we say that we don't have class labels here. He only knows that this is one thing and this is another thing. He doesn't know that this is an apple and this is a banana. So this is why we say that we don't have given class labels. All right. So what it will do is, what will he do is actually he will pick one apple one by one, he will pick one fruit one by one and check whether it's similar to this one or this one. If it is similar to this one and dissimilar to this one, then it will pick and keep it in this basket. If it is similar to this one, it will keep it in this basket, and it will actually make two parts into this. Okay, so this is how we actually, without knowing which one is apple and which one is banana, we actually separated them. So this is something we call clustering. So what we did is we had a bunch of data and we made a cluster out of them. We made actually two clusters out of them, and every clusters, the data points in each clusters have similarity, and data points between two clusters has this similarity in them. So this is our task. Okay, so this we can think of as unsupervised, the clustering task. Okay, and as I told you, in this we don't have the class label given. Okay, so the classification we have, and we have seen the clustering, and let's talk about the regression again. And let's say if I talk about the classification, let's talk about the classification in depth. Okay. Okay, so let's say classification means we have to classify into let's say if we have binary classification means we have two classes. Binary classification or ternary classification means three classes, and multi-class classification means there can be multiple class. Okay, let's say if I have some x and y coordinates, and we have some data. Let's say this is star points and this circle points. Okay, so what we have to do is actually we have to find out, we have to come up with some rule. If by seeing this from the eye, we can simply say that this one is one can say class, this can be the another class. So based on similarity and dissimilarity again, they will be actually belonging to some class, and the other data will be belonging to another class. So we need to find some rule so that we can actually classify them into one of its classes. Okay, now if I give one class here, one data point here, so what will you assign them? Which either this one or this one. So to come up with this example, we have actually a lot of machine learning techniques. So for classification, we have the KNN model. KNN stands for K nearest neighbor. K nearest neighbor. And then we have SVM, that is stands for support vector machine. So to do this classification task, we have KNN, we have SVM, we have naive Bayes, that is basically dependent on the probability theory. You might have known the you might have read this Bayes theorem. Okay, so this is actually based on Bayes theorem. We have naive Bayes, and then we have another model that we call decision tree. We have decision tree, and then we have random forest. Random forest is actually the ensemble method about this decision trees. Random forest and And another thing can be such as so the same way we can have a naive-based decision tree, random forest, KN, and SVM, and maybe I'm forgetting the name of some others. So these are actually our main classifiers. So each of them has their own algorithm. Let's say KNN or SVM or naive-based or decision tree or random forest, and they have actually their own methods of how do they pick actually the classes, the multiple classes out of them. And we have also logistic regression. Yeah, logistic regression is again one of the classification method. Logistic regression. You might have knowing this regression task, but this is actually used for the classification tasks. Okay. Again, let's say if I have these are actually classification tasks. So after this continuing of this class, we will learn about each and every model and see what are their working, and we will also see how can we code them actually, and how can we directly see the results in our computers. Okay, so we will have the coding for all. We will have the theoretical part of all, and we will see how actually they are working. We will see how can we implement them in our system. Okay, so and the next thing is the classification. We have regression. We have regression. So in regression, as I told you, let's say I have some raw data set. Okay, let's say I have some values of x, and we have this is x-axis, this is y-axis, and let's say we have some data like this. These are some data points corresponding x and y-axis, x and y data, and let's say these data points, and then we'll make actually a model. So we'll actually make a model here, and that will approximate this curve. If we are making a model, let's say if I talk about a linear model means it will be just a line. Okay, let's say this is just a line, and then if I say that this model is accurate or this model is accurate, okay, I'm making another model. So this model is nothing but fitting the line. Okay, let's say I make this model. So this second line, this line is more accurate than this one. So this one is linear, and this one is polynomial, maybe quadratic, or maybe 3-degree or 4-degree polynomial. Okay, so if I ask you which one is fitting the data well, this one is also getting the trend right, like the data is going up and the line is also going up, but this one is actually fitting the data really well. If you compare these models, so this model will have less error than this one, so we can think of that this is actually a good model. So now if I say that if I have to predict for some value x, we have to predict the y, then we will actually say, let's say at this point what will be actually value of y. So the corresponding value of y, with the help of this fitted model, this fitted curve, we can actually write the the value of y here. From the given x, we can give the value of we can actually see the value of y with the help of this fitted value, this fitted line, this fitted curve, you can say. So this is a typical regression problem, and this is how we how can we actually find this curve. This is actually the problem of regression. How can we find this line? Let's say not all points can be fitted with a curve. Some points, let's say we have some linear regression, we have some linear points, so they can be actually fitted with a line only. So how will actually we find the line? Let's say if I represent this y is equals to mx plus c, how will actually I'll find the value of m, or how will I find the value of y, so that it will just make this line. I can make a line like this, I can make a line like this, line like this, or any line, but how will I actually find the correct value of m and c, so that I will fit the line in this just correct way on the data just. Okay, so this is actually called regression problem. Whether it's a linear regression or polynomial regression, we have to find the parameters of them so that we can make a curve, and with the help of that curve we can actually approximate the data, and we can predict the new points within the data as well. Okay. So this is our task in regression. All right. Now, if I start it, so this is classification in regression. Actually, as I told you, talk about two kinds of regression. So we have the first one is linear regression, and the another one is logistic regression is actually a classification model. Linear regression and polynomial regression. So there are two kinds of regression model, and another kind of regression model can be, let's say here we have only x and y, and one of them, if I actually remove this y, which is our output, we have only one series which is x. So we have multiple values for x, and we have multiple values for y, and then we have to find out the relation. We have to find a function so that it will approximate those points and with the least error. Okay. Sometimes the one example that I gave for, let's say I have a car, and the car has let's say I will say that the car has this many cylinders. The car takes this many liters in 100 kilometers. The fastest speed is this. The price of the car is this, and based on these parameters, I have to find out what will be the output of CO2 given by that car in just 1 hour. Okay, so if I have to find this, so that we call multiple regression. Okay, so we can use either multiple, we can actually use multiple linear regression. So we have multiple data points in them, so we cannot actually mention it here. So we will actually go in depth if you are willing to take this course, okay, further on. All right, now so this one is actually the regression, and let's talk about the unsupervised method, which is clustering. Okay. So again I will take, so I had taken a very lame example while explaining that an orange is an apple and the guy doesn't know which one is orange and which one is banana, let's say. So here, let's say I'm talking about more mathematically. Let's say I have two data sets, so I don't know whether they belongs to one data or another classes. Let's say I have some data set here and some data set here. Okay, so if I ask you, based on similarity and based on this similarity, you have to divide these data sets into two parts. So what will be your containing two clusters, actually we can call it clusters. So I will actually divide this cluster. This is the one cluster and this is the another cluster. So why did I and how did I actually do this? How did I do this? This is the method of clustering. So we have another we have different kinds of clustering, such as hierarchical clustering. We have and in hierarchical we have both approach, top to bottom and bottom up approach. So and we have k-means clustering techniques. K-means clustering, we have DB scan, and we have some other clustering techniques. So if you are actually willing, we'll go inside and we'll go topic wise, then we will actually understand what is hierarchical clustering, and in this what is the top bottom up approach, what are the bottom up approach and top to bottom approach. So we have both top to bottom and bottom up approach. So both approach we will look at in hierarchical clustering, and then k-means and DB scan and all of them. Okay. So this can be a clustering task, and let's say, so this is clustering. So this is all we are going to cover in here, and so in classification and in clustering and in the regression task as well, we can use neural networks. So neural networks are something is the part of deep learning, as I introduce further. So deep learning, and then there are machine learning techniques. We talked about all those classification models. So these machine learning models, like this classification model that we talked about few class backs, this one k-mean, SVM, naive based decision trees, all of them are actually the statistical and the classical machine learning model. Okay, and all of like these clustering techniques, linear, polynomial, and multiple linear regression, they are also the classical models. And these clustering techniques such as hierarchical clustering, k-means, and DB-scans are also classical models. So when we use the same task, we have the same task, we have the same data, then we can also solve these problems with the help of deep learning. Deep learning means in this we will actually use the neural networks. So these models that we talked about, the KN and SVM, they are actually the algorithms, but again we can solve the same problem with the help of the neural network. So if you are using neural network, the same thing will be called as a deep learning techniques. So the theory of neural networks and some basics of neural networks are different than these classical models that we will look later on if you are willing to take this deep learning course as well. All right, so that is it about this machine learning. And the other type of learning technique that we call reinforcement learning. So here the reward and penalty policies are there. So based on some rules, based on some tasks that you do, so you do randomly something. Let's say there is a child, and if he's walking on the road, if there is something, let's say some obstacle, and he hits his the foot on that obstacle, and it will start pain or it will start bleeding, then it is actually a penalty for him. If he's let's say walking really great side, and if somebody is encouraging him, okay, that's you are going great, and nothing is happening to him, he reaches to his destination, so that is actually a reward for him. So we can say that this is the reward and based on the penalty. Let's say if he hits the obstacle on his foot, and then next time he will actually avoid this because he is understanding that this is not something that I have to do. So the example that I took for apple and snake game, so you can understand that what is the reward policy, I mean what is the reward and penalty thing in there, and how actually the agent, which is our snake, can learn and understand by doing same thing multiple times. He can actually learn and understand what are the rules of the system and how they can actually find the best way to maximize the reward. Okay, so the one we are actually the one to define the reward policy, what we when we have to give the reward and we have to exclude the penalties. So we are the one to decide them, and based on that rules and reward policy and the punishment thing, the game will understand the rules, the agent will understand the rule of the game, and it will start playing themselves. So this one thing can be thought of as a reinforcement learning. So yeah, that is it. If you guys have any question regarding this, you can ask me. And the explained session, the explained way of these classes maybe later on in this course. So if you have any queries, do let me know. Okay, so if you have any doubts, you can ask, or that is it in this session, the introductory session. And then if we will start doing the from the scratch from the next class maybe, then and you will be informed with it actually, then you will be able to understand the things from the beginning. Okay. All right, so that is it. You guys can enroll on the given link, given form link. You guys can enroll from there, and if you are there, we will meet soon. All right. Okay, so by just the ending of this session, I can simply talk about like the internship and what are the job opportunities from there. So once you learn these techniques about machine learning, and you will actually develop the understanding and interpretability of the data. So once you develop these kind of skills, the job opportunities you may get from multinational companies as a data scientist. So you will have the skills of understanding the data, and understanding these machine learning models, applying these models on the data, and drawing the results. So you can have multiple job opportunities on many companies. So as you know, the industry is generating so many data, so much of data, and we actually everyone, every company in every sector actually needs someone who can understand the data, and who can process them, and who can draw some good results out of them. So there are excellent job opportunities in this field if you're actually having a knowledge of these things. Okay, and you can actually have this, and you can also, if you're a college student, you can have some you can say the internship opportunities as well in various companies, and you can also have some internship you can say by taking this course and all. So yeah, that is it. And if you just want to further continue with this session, you can fill the forms, and then we will meet in the explanatory ways of this class. So we will come live, and you can actually see and access the contents of this class. And so yeah, that is it. If you have any queries, you can let me know. All right, so let's that's it from my side. Let's now, you guys can log off, and see you soon in the next classes, next set of classes. All right, have a good day. Bye bye.